Hello, my name is Eric Burris, facilitator for the Collaboration Network. CSU-WATER was founded in 2008 and is composed of more than 250 water experts from throughout California State University's 23 campuses and 7 off-campus centers. CSU-WATER not only fosters academic preparation, but also applied research and policy development that addresses all aspects of water use here in California. Today's webinar features 4 speakers. Our first presentation, Water Justice in California Central Valley, a case study of Matheny Tract, comes from Samuel Contreras of CSU Fresno. Next will be Jimmy Julinger speaking on the CSU Monterey Bay Watershed Geology Lab, Stories of Earth, Water, and Fire. This presentation will be followed by Transboundary water research along the U.S.-Mexico border coming from Trent Biggs at San Diego State University. Wrapping up the session will be Laura Ramos from Fresno State University, who will be giving us a presentation, California Water Institute, Connecting Students and the Community. Thank you for joining us today. We encourage communication and collaboration. So each presenter, the network encourages communication and collaboration. So each presenter's contact information has been made available here and in the webinar series agenda found on our website. Thank you for joining us.
And so I do have a film for this presentation, but I don't think that the time will allow us to show the film. So what I will do, I will share the link with you guys so you guys can later see the film on your own, because that's about 20 minutes. So I'll just give a kind of like a general background about the information in the Central Valley of the Institution about water, and then you guys can watch the film on your own. How's that?
Sounds great. Thank you.
Awesome. Well, thank you for having me. As Eric said, my name is Samuel Contreras. I'm an assistant professor here with the Department of Media, Communications, and Journalism. And so a lot of my research and my specialty is the community filmmaking, especially when it comes to empowering communities of color, Spanish communities, marginalized communities here in the Central Valley. The film that I was referring to earlier is my thesis film with my MFA in social documentation at UC Santa Cruz. It's something that I have actually picked up recently in my research. So I'll give you guys a little bit of the background and share a little bit also about my experience making this type of work in films as well. So in the California Central Valley, as you guys may know, is known as the breadbasket of the world, right? So we produce a lot of crops, a lot of, we have a big economy when it comes to the exportation of these crops, right? Not just here in the United States, but throughout the world. Right. And so we see that the Central Valley, it is a really rich land when it comes to not just the crops, right, but also financially. But unfortunately, we still see these discrepancies in many communities, specifically of color that are in the outskirts of the cities, what is called the unincorporated communities. Throughout California, we have about 500 of these communities throughout the state. Accounting for about 1 million people that to this day do not have access to clean, affordable drinking water. And Colorado Central Valley is one of those areas that is more affected by this. And of course, as you can know, also in the California Central Valley really relies heavily, right, on rivers and aqueducts. So, we transport water through canals, right? But also we are also depleting our salt water as well, right, to pump as much water as possible, trying to irrigate the crops. Right. And so irrigation and water allocation is still a very critical issue here in the Central Valley. And so who are these marginalized communities I was referring to, right? So specifically, there are farm workers. This is in these communities that are not incorporated. Most of these communities are populated by Latinos, farm workers, and African Americans. So just a brief history about these communities. We had a lot of migration, for instance, in the 1960s from the South, escaping the Jim Crow laws. And so they settled here in the Central Valley. And so, but they were city codes in which they cannot purchase or even rent in the city. So what they will do, they will pitch in money to buy a plot of land in the middle of nowhere. And so these communities unto this day, because of that, they're located literally in the middle of nowhere. They have no sewer system. They have sidewalks and have streetlights. And once again, this is the legacy of that those racist policies. And to this day, they're still this communities are still suffering because of that. Um, and so also, a lot of these communities, like I mentioned, they are not connected to the city water, for instance. So they rely on private companies that actually manage the wells they get the water from. And so what is happening as well is with these companies that they charge the residents about twice or sometimes three times as much as the people in the city. And this is our low income communities. So it just a really harsh burden for these families to spend about even 10% of their own and the wages just on water alone. And once again, it's a really low income communities. So 10% for these communities, it is a lot, right? And once again, these communities are heavily impacted to this day. And so, why is it important, right, to look at this issue of water also to a social justice lens, right? Because I think it is important to highlight, right, to this issue in which sometimes perhaps the mainstream media might not give them a lot of importance, a lot of coverage, right? Something perhaps that we have accepted as normal, which is obviously it's not, right? So it is important to highlight these inequities that exist throughout the California. Once again, the fifth largest economy in the world, and it can even not provide water for the basic fuel of life for the residents here in the state, right? And so it is important to empower those voices, right, to demand their rights as citizens of this country, right? And how we have rights. So it's important to, for me especially, to document their journey, to document their fight and their journey to have access to clean, affordable drinking water. And why is it important to to incorporate storytelling into research, right? Because I think lots of us are researchers, right, by training, because we love doing this type of work too, right? But sometimes we get lost, I feel, on the data itself, right? And we lost that human touch, which once again, these conditions of lack of affordable drinking water affect humans directly in our communities. So it is important to provide the context, right, and also in an emotional matters, as also as a call for action. If you see something, you feel something, most likely you create empathy, and the empathy perhaps can create movement, right, in the fight for social justice at the end of the day. But also some of the benefits about incorporating this notion, right, or storytelling into research is to enhance our understanding of these issues, right? To really see the struggles of these folks, everyday struggles, really is what it is for these folks in these communities, right? That they actually fighting every single day for their own survival, right? Just to have access to clean, affordable drinking water, to have even sidewalks, to have street lights, right? There, it's a constant struggle for these folks, unfortunately. And it's important to understand the struggle. And I think by doing it visually, it's really empowering overall, right? And yes, I think once again, the research can really have an impact as well, as I mentioned before, right? Because also perhaps we can change and promote policy change, right? And community empowerment, which is something that I try to do with my films when I tell a story. It's just about, for instance, of this poverty porn, as we call it, right? It's more about, this. It's not about, oh, look at these poor folks in these communities, right? No, it's not about that. It's about empowering those, right? Feeling proud of their work, feeling proud that they're actually fighting for something, right, for their own existence at some points. So it is important for us as researchers, as scholars, to really incorporate not just the data into the research, but also this humanistic impact. Because once again, these folks are directly impacted by the lack of clean, affordable drinking water. And so, like I said, I want to keep this briefly. And so kind of takeaways about this, once again, water, it is a really important vital resource, specifically here in the Central Valley, as we have, once again, a bunch of crops because of agriculture. But we also have people, once again, that are affected by this lack of clean water, right? And it's important to understand how marginalized communities really struggle, right, in the face of these challenges, but also understanding and empower them to have the voices heard in every opportunity that they can, once again, so that the future, hopefully, they'll, all the communities, all the people in the state of California, and hopefully in this nation, right, we have use the basic right of having clean water. And so, yes, this film, which I will share the link with you a little bit. I will share, like I said, so the film is called The Battle for Matheny Tract. And so Matheny Tract is one of those communities I was referring early, in which they are unincorporated into the county or the city, right? And so the reason why they're not incorporated into the county or the city is because they want to maintain the level of independence in a way, right? Or autonomy, in which, for instance, they want to have goats, they want to have animals, livestock, and their own property. They're allowed to do that. If they were to merge with the city or the county, they would not be able to do that, right? In the past, even the city and the county, they're trying to destroy the cities because it is easier for them just to literally destroy the community as opposed to providing infrastructure to connect them to the water city, for instance, right? So once again, it is a constant struggle just for the survival of these communities. And so the community of Matheny Tract is particularly a case study in which when I came to document them in the summer of 2014, they were had about 10 years of ongoing organizing. The community having the lack of clean water for the longest time. And so, and so they are actually one of the few and first communities that actually beat the state and in suing them, so they can be connected to the city water, for instance. And because of them, actually, after the specific victory, which you will see in the film, they actually, the governor and even a lot of nonprofits have been doing a lot of activism, introducing bills to provide water to these communities, for instance, right? And so in the last several years, now the government in the state of California has been giving more resources for these communities, right, to have that right of clean water. And so this film in particular took about 2 years to produce. As I mentioned, this is my film for my master thesis, and actually I just finished. Unfortunately, this issue of lack of water is still going on, and it's pretty prevalent here in the Central Valley. And so actually this summer, along with my students, we produced another film, which I think I'm gonna upload by the end of the day, and I'll definitely share the link with you guys as well. And so once again, it's the importance of telling these stories, right? And I'm also proud to say that I just got a nice grant for Measure P here, the Fresno Art Council, to produce a feature-length film about this issue. And so we're going to continue, once again, giving a voice to the voiceless. We're going to continue documenting the stories. We're going to continue empowering this community storytelling and research, right? So they have been, they can be motivated to keep on fighting, and also the public in general to feel inspired and feel some empathy, right? So that everyone in the state and hopefully in this nation, where everyone will have access to clean, affordable drinking water. So like I said, I'll paste right now the link of the film into the chat. And you guys, when you guys have some free time, definitely I will encourage you all to check it out. It's not that long, it's about 17 minutes. And I think that concludes my presentation. If you have any questions, let me know. I think we have a little bit more time.
Thank you.
Yeah, thanks for inviting me. This awesome lineup of speakers here. So just like Eric mentioned here, I'm going to be talking about our program here, our Watershed Geology Lab, that I basically took on this role as an assistant professor here at Cal State Monterey Bay just 2 years ago. So I'll be talking about some of our student-centered applied research projects here at Cal State Monterey Bay. So just to kind of give some context here too, because we're a little bit of a smaller campus, CSU Monterey Bay, we're, I guess I would argue here through some of the, or one of the case studies that I'm going to share here, that we're a hub for experiential learning and regional stewardship. So we're actually the second youngest CSU. We were founded in 1994 on the former Fort Ord Army Base, which was one of the, I guess it was the largest Army base on the West Coast up until it was decommissioned. And this is a little picture of it over here too. We're right along, we're the closest CSU to the coast actually. And we have a student body. We're one of the smaller CSUs, a student body of about 6,500. Primarily Hispanic serving institution, and a majority of our students are actually first generation students. So with that, we get relatively high marks for, along with many other CSU campuses, for social mobility. And part of our mission here too is, in terms of our mission statement too, is really centered around student success, inclusive excellence, and then what I'm going to be really focusing on here too is regional stewardship. We are situated along, one of the treasures in terms of marine sanctuaries of Monterey Bay. And as a watershed scientist too, I work on problems that are related to, and me and my students work on problems that are related to impacts between the terrestrial system and marine system. So this is just a little snapshot of, or at least this was our lab back in the spring of this last semester. And so I'm a geomorphologist by training. So I focus both in my research and teaching, which kind of has a gray area, honestly, between it too. And you'll see that with this case study. A lot of my teaching is wrapped up with my research. My expertise is in geomorphology, hydrology, and then we use a lot of remote sensing tools and precise land surveying, actually, too. Some of my students go on to I had one example of a student this last spring who's actually going into a career of doing professional surveying as well. And so at any given time, at least the last few years, I'm mentoring about 8 to 10 undergraduate students and then 3 grad researchers. And I'm taking on a few more of those this year to work on similar problems that what I'm going to be talking about here. So some example projects. I want to make sure to respect time here too, so I'm only going to talk about one of these. But some example projects and collaborations that we have ongoing are all kind of centered around applied watershed issues. So things like erosion hazards. I work a lot on local issues related to landslides of various sizes. So hill slope instabilities. This is a picture here too of an eroding gully system that's actually fed by a local landslide here in the Monterey Bay region. And continuing on from my PhD and postdoc work too, I do a fair bit of work looking at post-wildfire erosion and things like post-fire debris flows and hyperconcentrated floods, which is really an issue that's not going away here in the state of California and really broadly in the Western United States. And I am actually part of a team with NASA where we're trying to use some of their remote sensing systems to help improve situational awareness following wildfire. And then I apply a lot of these issues also to river and estuary science. And most of this work actually is within basically an hour radius of campus here in the Monterey Bay region. So I work in an area that was impacted by recent fires in Santa Cruz in the Scott Creek estuary, which is slated actually to have a fair amount of restoration projects for it. And then what I'm going to be focusing on today is the Carmel River watershed. So I'll talk a little bit more about the kind of regional context with that. But I work with multiple different stakeholders and partners here, including federal agencies like the USGS and Inland Marine Fisheries, and then some local water districts and conservancies. And so the case study that I wanted to talk about today, to kind of just give you a sense of what the sort of work that we do, is situated in the Carmel River watershed. So the Carmel River is it's a really special river here in the Central Coast. If anyone has driven from Monterey, south along the Big Sur coastline, which is basically is pictured here, this is the first watershed you would basically encounter here. And it's because we're sort of isolated here in northern Monterey County in the Monterey-Carmel metropolitan area from any major state water projects and federal water projects. We're actually sort of on our own here in terms of water. And so the Carmel River actually, since the beginning of modern settlement of the area, has been the conventional water source for the area. And it hosts a lot of endangered and threatened species, including South Central Coast steelhead trout, who use this for spawning territory. And there's been this tension too for many decades of actually the lower alluvial aquifer and the lower Carmel River was the conventional water source for the region, along with some dams too. and it was actually illegally overdrafted for many decades, leading to some habitat degradation. But a cease and desist order coming down from the state water boards has actually been fully enacted as of 2022. And thankfully, the area we seem to be coming out from under that too, because we've switched over to a lot of less conventional water sources like water reuse and managed aquifer recharge in the region. So things are looking a little better from that standpoint, but there is sort of some contention around that, and there could be a whole talk about that. But because of all of this too, because of its, it's really important habitat. It's actually a groundswell right now, as of the last few decades, and now for major restoration projects. One of which was actually a dam removal project that happened that at the time before the Klamath dams are coming down in Northern California and in Southern Oregon right now. But this actually was the largest dam removal in California history prior to those. It was kind of a unique project in the way that they did it. That was done actually primarily because it was a seismic risk. It was a really old dam that had silted in its reservoir. The hope was that it would open up and do passive restoration essentially for steelhead habitat along the river. But what I'm going to be focusing on is a recent capstone project actually that was enacted by my students here in a large conservation preserve in the Carmel watershed, or most of it's in the Carmel watershed. Some of it actually drains to a different watershed, but I'll be talking about a goalie study there. So the Santa Lucia Preserve is actually one of the largest conservation land holdings along the central coast of California. 18,000 acres of permanent conservation land trust. Very biodiverse area. It hosts those steelhead habitat for some of these tributaries to the Carmel River. And this last year, we've had a somewhat long-standing relationship my department has with Santa Lucia Conservancy, who runs the preserve. And they approached us to develop a goalie inventory following these recent wet spells that we had, in particular 2023, where the Central Coast was hit really hard by the spate of atmospheric rivers that led to significant runoff and flooding. And so what is a goalie? So this is actually a picture of some of my students here working on a goalie out in the preserve. So they're channelized features on hill slopes that form basically in response to disturbance events, some of which can be natural, like wildfire, but what was more relevant here is things that can basically exacerbate runoff on hill slopes. So things like stormwater drainage or cattle grazing. There's even wild pigs that are actually running around the preserve too that were indicated to be potentially a cause there. And so this basically formed the basis for a spring capstone project for a dozen students, basically the ultimate course that my students take through a watershed science program that we have here at CSU-MB. And so I'll present some of the initial study findings here. So what my students ended up doing, so they were basically developing this spatial inventory of goalies across this 20,000 acre preserve. Kind of basically what they're doing with these capstone projects is applying all of the knowledge that they learn in our applied environmental science program here, which includes a lot of geospatial analysis. So one really cool thing, I love LiDAR, and this is a picture here, 3D GIS scene of LiDAR, which it stands for light detection and ranging. The state of California and really across the Western US has been able to acquire this laser mapping platform where you can think about this as like an order of magnitude increase in our resolution of topography compared to topographic maps. And so what my students did is they took recently available LiDAR maps across the preserve and then mapped these potential goalies, these channelized features, which are shown here on the left. But of course, we teach them, you can't just rely off remote sensing completely for a lot of this sort of work. You need to go out and ground truth these. So what they did is they developed a plan to drive the roads out here and some of the hiking trails to go out and see, are there in fact goalies out on the landscape here based on the LiDAR pre-analysis, and then made field observations about the sizes of the gullies. And then really, the important thing here too that we wanted to come to the preserve with is why those gullies are there. What sort of initiation mechanisms are we talking about, and types of disturbance that could be leading to these gullies. And what they basically did this last spring is confirmed out of, I think it was about 60 or so potential gullies, they were able to confirm 43 across the preserve, shown here on the right. And most of the gullies were situated near roads, so that already sort of told us, okay, potentially related to road runoff and culverts. And in fact, that's what we found, is that most of them, about a similar fraction to what we're actually eroding, were also likely triggered by stormwater runoff, but exacerbated by a pretty erosive geology in this region, which I'll show a little bit more on the next slide, because this area here too is pretty honkin' steep. It's a tectonically active area, just like the Big Sur coastline is. And so it's exacerbated by this geographic context. And another really kind of great thing that the students did too is that they went back to the GIS to do some geospatial analysis based on each of those individual points, and then plotted those points actually using that LiDAR data. They looked at this. Each one of these points basically represents a gully head, so the head of these gullies, and plotted their position in terms of how steep the slope is at that gully head, and then how much area is draining to each one of those gully heads, which is basically a proxy for how much runoff could be routed towards those gullies. And so you can kind of think about, if I move from the lower left to the upper right quadrant here, you need increasing erosive energy required to initiate these gullies. And what they did is we plotted all these gullies in terms of those topographic positions, and then developed a threshold line, basically a lower bound for what we thought, okay, this is where we think gully susceptibility is happening. If you cross this line from lower left here to upper right, this is your susceptible terrain. And they compared it to a global data set of these initiation threshold lines. And we found that, yes, Santa Lucia is in the upper rank here in terms of erodibility, potential erodibility, and that when you looked at the whole preserve here, it was greater than 50% of the hill slopes are susceptible to gullying. And this can assist with land management practices here too, because these gullies, I didn't mention this before, but they're really seriously thinking about how to repair these things or prevent, in terms of land preservation, prevent them, because they can deliver, pretty significant amount of excess fine sediment into steelhead habitat that's hosted on the preserve. So some applications and conclusions here. The Santa Lucia Preserve has very erosive soils compared to global data sets. Most gullies seem to be associated with road and culvert runoff processes. And what the students also did too, we went to the preserve too with all this and wrote up a report and everything, and presented it. And they also did a lit review on different approaches basically to gully repair that could be tailored based on our information, specific to each of these gullies, because there's no one size fits all approach here. And I know in particular the types of restoration that this conservation holding is really interested in is more of these soft approaches like revegetation. If it, in fact could, if that was a potentially relevant way of dealing with some of these. So this work is ongoing. It's hopefully going to turn into a multi-generational project where students are going to, each capstone can build off of the previous one, where we can make sure we have the inventory tied down. We can start to prioritize which gullies might be good candidates for restoration and more impactful. So this is just one example of what we do here at CSU-MB in terms of really getting the students working on applied projects where, in the real world, they're experiential learning and see themselves as watershed scientists, and turn the crank on all of that. And I wanted to end here actually with some good news that's relevant probably to potentially a lot of people on this call. We actually received, I'm going to be PI on a NOAA grant that's been funded through Inflation Reduction Act funds administered through NOAA, where over the next 5 years, starting this upcoming year in 2025, we're going to be able to fund 40 undergraduate and 6 graduate internships related to climate resilience work. So a lot of overlap, obviously, with what we do here in terms of CSU-WATER and all that, and we're looking for regional partners as hosts, basically, regional partners who need students who work to work on climate-related aspects of things like water resource management. So things like the State Water Board here in Region 3 in the Central Coast, because it is regionally specific. So you can feel free to reach out to me if that interests you. And that's basically it. I'm happy to take any questions.
Thank you, Jimmy. We have one question in the chat, and then while that's being answered, if Trent, you want to gain access and share your presentation.
Yeah.
So the question that was in chat, do you consider annual rainfall in these areas?
Yeah, so that's something that we were looking at. We were looking at PRISM data because there is sort of this orographic gradient of precipitation, like mountains kind of influence the way the precipitation works out here. And there actually didn't seem to be too much of a climate signal. They're probably interannual variability in precipitation, of course, is really important probably for initiating a lot of these goalies. And, there could be future work with some of these students actually looking at that too. How, I'm assuming it's probably related to ENSO cycles. But that's a great question. It seemed to be a lot more related to, infrastructure. And then there was some signal related to the types of geology out there too, as well. Great question.
Thank you, Jimmy. Great presentation, fantastic science applicable to areas throughout California. Next up is our presentation from Trent Biggs, Transboundary Water Research along the U.S.-Mexico border. And I'm excited to hear about this because San Diego State University is my alma mater. I was one of the last 2 zoology students to graduate from San Diego State back in the day. Thank you, Trent.
Oh, that's great. Nice to meet an Aztec alumni. That's great. Okay, so I'm Trent Biggs. I've been at San Diego State since about 2007 in the geography department. And for reference, most of the material I'm presenting here is available either on some combination of my website, biggslab.sdsu.edu, or on the broader umbrella website of water research being done at SDSU, which is bluegold.sdsu.edu. I'm going to be focusing on water issues along the U.S.-Mexico border region, but more specifically on some recent research we've done on water quality, since it's so in the news, especially the sort of ongoing sewage problem in the Tijuana River. But I'm only I'm one of many researchers at SDSU doing research on water. And in 2015, we formed a group called Blue Gold, Mitigating the Effects of Water Scarcity. And that's since grown to 17 faculty from 4 different departments across the university. And if you're interested in seeing all the different focus areas of the people in that group, please check out the website. There's ample opportunities for collaboration across a wide range of issues. Another initiative that we have at SDSU that sort of grew out of the Blue Gold initiative was called the Water Across Borders Initiative. And our goal is to foster water-related research, especially collaborations between SDSU faculty and collaborators at institutions in Mexico. And we've had some success in funding pilot projects where there's one PI from SDSU and one PI from an institution in Mexico. And we look forward to that work continuing to grow. So in terms of the critical water and sediment issues on the U.S.-Mexico border, there's 2, I think of them as being, starting out with sort of 2 major regions, the Tijuana River watershed and the Imperial and Mexicali Valley in the east. And the Tijuana River has issues with cross-border sewage and sediment problems. And I'll be focusing on that today, and some of my former PhD students, Napoleon Godino, Elizondo, published a number of articles on the sediment budget of some small watersheds that drain into the Tijuana estuary. I'll be mostly summarizing some work that I've been doing with Natalie Mladanov's lab on water quality. And then in the east part there, around the Imperial and Mexicali valleys, one of the areas that we have done some work is on the groundwater-driven wetland collapse. So there's some wetlands that formed along the U.S.-Mexico border in Mexico as a result of the leaky, inefficient All-American Canal that was previously unlined is now being lined, and that lining is reducing the recharge, which is causing those wetlands to collapse. And we've published some of that research with a master's student here. But the specific research project I'm focused on is on real-time and remote monitoring of sediment and sewage contamination in the Tijuana River and estuary. And this involved 4 co-PIs at SDSU. It involved 2 co-PIs from the EPA, a co-PI from the Tijuana estuary, and JIBE, which is works on remote sensing of water quality. And it involved a whole bunch of students over time. And we're grateful for funding from the J.W. Sefton Foundation, first off, and then the EPA, a NOAA grant to train graduate students in remote sensing technologies, and some extra funding from SDSU. So the motivation for studying this is that there's persistent sewage flows in the Tijuana River, and that's been true since about 2022. We've had 800 now, I guess 900 consecutive days of cross-border dry weather flow, and it has this signature diurnal oscillation that corresponds with wastewater production dynamics from Tijuana, and the Tijuana River flows from through Tijuana and then over into the U.S. and flows into the Tijuana estuary and out to the ocean, and that's resulted in sort of persistent water quality problems on both sides of the border, both in Playas de Tijuana and in Imperial Beach. And so this is sort of an ongoing issue. But surprisingly, the Tijuana River, especially stormflow, has not been sampled in any regular or systematic way since 2014. That's when the last water permit was issued for it. And it's never been monitored continuously or in real time. The second problem is that collecting samples, especially for bacteria analysis and analysis of organic matter and things like that we care about, is time-consuming and expensive to collect. There is a continuous monitoring station at 2 locations in the estuary established by Jeff Crooks and the Turner Group, and they monitor dissolved oxygen, salinity, and turbidity, which is very helpful for monitoring ecosystem dynamics, but it's not useful for estimating concentrations of bacteria or monitoring sewage or organic matter concentrations. So we really wanted to develop a real-time monitoring system for sewage and bacteria. So there are some options to do that. One is fluorescence, and I guess the double question mark should be an arrow pointing to the right, which can estimate wastewater and bacteria. So there's 2 things that you can measure. One is tryptophan-like fluorescence, and that's been shown in other studies to be a proxy for sewage and bacteria, or chromophoric dissolved organic matter, which we found in the end has too many natural sources and that complicates its use for sewage detection. And there's 2 ways that you can measure both of these things. One is with a portable sensor in the field, the MANTA, and I'll be talking about both of these. And that you can deploy in the field. You can leave it there. It has a wiper for anti-biofouling and can provide continuous. You can hook it up with telemetry to get real-time measurements. And the second way is with a benchtop fluorometer called the Aqualog. And for that, you have to get a water sample, take it into the lab, filter it, and read it through the Aqualog. So previous work by Natalie's group has shown that the tryptophan fluorescence on the y-axis here correlates pretty closely with E. coli concentrations. And so, but it hasn't really been tested in the field under dynamic stream flow. So we wanted to know, how well can we estimate sewage and bacteria concentrations in near real time? What is the percentage of untreated wastewater in the Tijuana River? Because there are wastewater treatment plants upstream in Tijuana, but and so in order to understand the scope of the problem, we need to know what is the percentage of untreated wastewater, and how contaminated is the estuary? How much of this of the pollution actually reaches the estuary, and what are its dynamics there? So we deployed 2 of these MANTA sensors that measure temperature, pH, conductivity, dissolved oxygen, turbidity, tryptophan, and CDOM. And we have them at the International Boundary and Water Commission station, which is right after the Tijuana River crosses the border. And then we have another one at Boca Rio, which is a tidal arm, tidal branch that comes off the main stem of the Tijuana River. And so we deployed those in 2021, and this is what the deployments look like. One is on a buoy, so you have a sonde housing, and then we have a hyperspectral camera to take coincident measurements of the spectra of the water. And then at the IBWC station, it's just a little PVC pipe housing, and then there's a telemetry system that broadcasts it back to a website for real time. So we then measured the turbidity, tryptophan, and discharge at the Tijuana River site, at the IBWC site, right where the Tijuana River is coming across the border. And we noticed that the tryptophan signal becomes very diluted during storm flows, while turbidity goes up during storm flows, which is to be expected. But what we found is that the turbidity was causing artificial depression of the tryptophan signal. And so we developed a turbidity correction factor, and that, which is shown in blue, the time series here, correlates pretty darn well with the E. coli concentrations. And so you can see that right for the beginning of the first storm, which is this black, the discharge is shown as a black line in all of these plots. But for the first peak in the storm, there was some increase in E. coli from the base level of 0 right before any flow started. And then in the recession flow, in the recession limb, the bacteria concentrations increased as the dilution from the storm flow decreased. And then there was a second storm where you had a really high concentration that was actually captured pretty well by the fluorescence. So these are plots of the aqualog versus aqualog tryptophan versus E. coli, and the MANTA tryptophan corrected for turbidity versus E. coli. And the aqualog does great. I mean, benchtop fluorometers are the way to go to estimate as a proxy of bacteria concentrations. The MANTA does pretty well, but there's a lot more scatter and differences by events. So the second question is, what's the percentage of untreated waste sewage in the Tijuana River? And so we did wastewater addition experiments, and we added sewage to either seawater or freshwater, and then monitored the tryptophan response. And what we got was, for the aqualog, sort of similar story. The aqualog, great. I mean, if we know the aqualog tryptophan, we can estimate the percentage wastewater. The MANTA saturates at around 40 to 50%, and then actually starts to decrease. And I can go into details of why later. But that means that we really in order to estimate the percentage wastewater, if it's really high, we need the aqualog. So here's what the aqualog says the percentage of untreated wastewater is in the Tijuana River over a sampling period from May 16th, 17th, and 18th of 2023. And that varies depending on which wastewater addition experiment you use, because the strength of the wastewater varies over time. But it suggests that the percentage wastewater is between 40 and 80%, with gradually increasing amounts over the 24-hour period. So we're trying to get some more resolution on how the wastewater wastewater percentage varies over time here. And then how contaminated is the estuary? And this is based on a paper that just came out last week, evaluation of real-time fluorescence sensors in the estuary, led by Natalie with a bunch of our collaborators. And just really quickly, in the interest of time, what we found is that how contaminated is the estuary really depends on the tides. So if you have a spring tide where you have really low lows and really high highs, in general, the water's cleaner, shown by the blue line here, which is the tryptophan. The gray is the depth of water in the estuary. So high tide coincides with low tryptophan because you're getting dilution from the ocean. And then there's these few spikes where you're getting a lot of contamination in the estuary just at the transition from low to rising tide. And we think basically the water is damming up the water from the ocean is damming up the flow from the river and causing these temporary high spikes. And then for neap tides, where there's not as big a variation over time, that's where you see persistently bad water quality. And that's where we also see persistently low dissolved oxygen. So the dynamics of the contamination in the estuary is driven by the tidal exchange, and these graphs also show how important it is to get high temporal resolution sampling, because you can't just walk out there and get a sample of the estuary and assume that that's representative. So we had challenges, fouling by sediment and organisms. You have to do frequent maintenance 2 to 4 times a month, depending. Staff time, training, sustained funding. These are all sort of persistent issues. But we are interested in developing real-time warning system. We have it for air pollution. Why not for water? And we're interested in transitioning from these sensors, which require a lot of field maintenance, to hyperspectral and ground-based cameras. And some of our wastewater addition experiments suggest there's potential there. We want to map hotspots and hot moments of pollution, and then establish a sediment and bacteria budget of the estuary. So with that, I will stop the presentation and take any questions. Thank you.
So we have a lot of students that work on, my name is Laura Ramos, and I'm the interim director at the California Water Institute at Fresno State. And we have a lot of projects that involve students, but especially a lot of projects that directly affect the community. We are a research center that connects the water problems in the San Joaquin Valley and all of California with Fresno State faculty, staff, and students to try to find solutions to some of those water challenges in California. We have students working on a lot of projects, but today I'm going to concentrate on 2 key projects. One was the City of Fresno Regional Consolidation Study, and one is a groundwater recharge feasibility study. So I'm going to start with the City of Fresno Disadvantaged Community Consolidation Study. And what we were doing here was what we wanted to see if a regional consolidation was more financially effective than individually. So the City of Fresno has a lot of small communities that depend on wells for their drinking water and that are close enough to the city that they could connect to their water utilities, but they had not connected. And instead of looking at each individual one and what their vulnerabilities were, we wanted to look, can we connect multiple at the same time and save some money? For example, there were some that were on the same street. So if we're opening up the street to connect them, if we do it once and connect 2, that is going to save some money. And so the study was specifically looking at all of those, what were their vulnerabilities, and how we can look at all of them at the same time. And part of the reason why we were doing this, one, we wanted to reduce the vulnerabilities of some of these communities, but also we wanted to take advantage of economies of scale. If some of these communities did things on their own, it would cost a lot of money, but connecting them to the City of Fresno would save them some money. And so what we did, it was actually a class of civil engineering senior students that did all of the feasibility study, and they looked at each one as well as what was funding that was available through the SAFER Fund at the time that we did the study. They looked at, is a looped connection or direct connection feasible, which one would cost more money? What was the total annual demand? And what would it cost to put them all together? And what would the savings be if we did all of this at one time or individually? We actually, with the feasibility study, we were able to show that all 12 connections were financially and technically feasible. We then did a lot of outreach to these communities to see if they were interested in working with the city of Fresno to connect them. The city of Fresno was open to connect them, and every single one of the 12 communities said yes, and they're actually on their way to be connected and consolidated to the city of Fresno, reducing their vulnerabilities to having safe drinking water for their community members. The other one that we did, a lot of the communities in the San Joaquin Valley aren't lucky enough to be close enough to a community that can connect them because of the distance, and it's just not financially feasible. The only way that they have access to water is through groundwater. But as we know, groundwater levels are reducing, and a lot of these communities have wells that are going dry. And so the only option for them is to increase the groundwater level around them. And so for that, we did a feasibility study for Fresno County to look at which are the best recharge areas that fit multiple criteria, but one specific was that they were close enough to a disadvantaged community that they would help increase the level of groundwater near them. And so we identified very many different sites, and then we narrowed down to the sites that were near the communities. And the ones that were identified were Kerman, Raisin City, Carruthers, and Layton as some of the communities that could be benefited from doing recharge near them. And so then this was another one that was taken into a classroom. And again, there were civil engineering students that looked at were they technically and financially feasible. We can identify the best site and the community that most needs the help. But if we can't get the water there, then it doesn't really matter if it's not financially or technically feasible. And so these 4 communities were identified as being financially and technically feasible to do groundwater recharge near them, and identified a best site for them that would benefit them long term. We then did some educational sessions and material to distribute to those 4 communities, because we believe that groundwater recharge will start happening in all of rural California. And a lot of these communities that live there don't know what groundwater recharge is, how it's going to benefit them, what are the potential concerns. They're going to know that one day they're going to wake up and there's going to be construction in their backyard. So we actually did some flyers in English and Spanish and distributed them to all of the communities to let them know what it is, what are the benefits, and what are some of the potential concerns, and what can they do about those concerns. And they could call the California Water Institute with any additional questions. Also, just brand new, we have a water miner that we just completed in the spring that we launched for all of us students. And the idea there is, just like in these 2 studies, you were looking at more than one area of interest. In these, you're looking at agricultural land that might be used for recharge. You're looking at engineering students and agricultural students. And so the idea with our brand new minor is that somebody that is an engineer will take an ag class, an environmental class, a disadvantaged community class, and a political science class. So as they're constructing new things and going through new communities, they understand how they're going to impact them. If they're an earth and environmental science student, that they're taking an engineering class, an agriculture class, a disadvantaged community class, so the same way as the others, so that they understand all of the other water interest groups that they're impacting. We believe that more and more all of these different areas are going to work together. So what better than to graduate students that come with a basic understanding of all of those other interest groups that they're going to impact and they're going to have conversations with if they've taken a class in each of these areas. So just like the environmental and engineering students, agricultural students will be able to take an environmental class, political science class, engineering class, so that there are more well-rounded students. Thank you. And I might have done that a little too fast, but I was trying to make sure we kept to our time. So any questions?
Thank you, Laura. I think you hit all the high points, and I love seeing the multidisciplinary courses of education. And I have a comment or a question for Trent. Have you tried using any fluorometers that are portable and using them out in the field?
Yeah, we've used a portable fluorometer, handheld, and it does okay. I mean, overall, what we found is that the correlation between the handheld fluorometers and the bacteria is okay at is not very good at low concentrations, but pretty good at high, getting the full range from low to high concentrations. So it has to be pretty dirty to really have it be a good indicator. So the portable we've used, we haven't had quite as good a luck with them as we have with the Manta.
All right, thank you. Your hand's up.
Yeah, I wanted to ask Laura, do you have any like a list of the projects that you've done and the sort of project portfolio? Because I'd be really interested in seeing the range of projects that you've done and what kinds of activities you're engaged in, because it's a great model for engagement between universities and the community.
Yes, I do. We're redoing our website, and some of them are on there. They have our current ones and then some of our past ones. But I can make sure I send you some of those, because most of what we do is outside in the community.
Got it. Thanks.
Okay, Steve sent a question in via the chat. He would like to know more about the study that includes Raisin City.
Do we have his email address? We can send him a link to the publication where it talks about the entirety of the thing and all of the work that the students did.
I'll make sure that you get that, Steve.
Yeah, I could ask
Jimmy.
Trent a question, I guess. Yeah, Trent. Yeah. So you were planning on developing a sediment budget for the estuary. Were you planning on using like turbidity as a proxy for that? Is it a pretty good proxy for the sediment concentration in estuaries? I know that can be challenging.
Yeah, I know. Yeah, we've collected some samples of suspended sediment, and it does well enough to give us a kind of order of magnitude. But the biggest problem is instrumenting the outlet, because it shifts all the time, and so if you put in a turbidimeter, it's going to get buried. You know, the outlet shifts by tens of meters during any given event, and so we're all ears for how to efficiently and effectively monitor the outlet of an estuary, because oh my goodness, it's hard. That's one reason why we're on this tidal arm, which isn't as representative of what's actually getting out to the ocean, is because there's just too much sediment moving around near the mouth. But we are measuring the discharge, and we're establishing a water level discharge relationship using at ADCP that float around with Xylem, one of our community partners. So yeah, long-term goal. Yeah.
That's great to hear. We have a hand up from Steve Blumenschein, whom I've worked with to make the webinar series work. Thank you, Steve, for allowing us to be a bridge to the water quality monitoring community through the Monterey Council's network, as well as just the water board as well. That'd be great.
Thanks for that, Eric. It was so exciting to hear from you just a few days after the conference and the networking event to set this up. So thanks to everyone who put in to give a talk, and it's really great to see. I have a question for everybody, but I'll keep it short for Trent. Trent, sorry if I missed this in your talk, but did you consider or have the ability to use stable isotopes to track that? So some work I did quite a while ago in Thailand, in one of the major rivers that goes through Bangkok. I mean, that's a subtropical area. So there was lots of aquaculture on the land. And Laura, as you can imagine, there's no need for irrigation when there's like hundreds of inches of rain a year, but everything is flooding off the land, and all the alligator farms and fish farms and shrimp farms and rice farms, you name it. And part of the issue was that there was so much nitrogen coming off the watershed in the country in that region that the Gulf of Thailand, which received these rivers, and by the way, Bangkok, a city of 10 million people without a whole lot of sanitation, was at the mouth of the Gulf of Thailand, which was really going hypoxic much of the time. And so looking at the sources of nitrogen was pretty critical. So we kind of dabbled in looking at different runoffs from various areas on the landscape in that urban agricultural landscape, which was pretty amazing. and trying to do some source tracking just with stable isotopes is kind of a first cut. Did you have stable isotope considerations here or applicability? Because sewage, like fertilizer, often has, you know, an enrichment pattern with N15 that's traceable. Anything like that come up?
No, I mean, I think in terms of like our main preoccupation is with pathogens and indicator bacteria that show how much sewage there is and what the public health implications are. So I think I think you're spot on though, that there are like feedlots upstream. There's a lot of agriculture, so those could also be contributing bacteria and sort of sewage-like material.
For the diseases and disease indicators, something we did here in the San Joaquin River in Fresno, I did with some faculty colleagues a while back, was to use qPCR for the human-specific disease-causing bacteria, like those E. coli strains, for example, or Enterococcus. And by the way, the Q and qPCR stands for quantitative polymerase chain reaction. PCR just tells you what strands of genetic material you have that are specific to organisms, and then Q stands for quantitative. It's not just indicating is that type of organism in the water or not, but it's the relative amount based on the genetic material.
Yeah. So, yeah, there's a professor in civil engineering, Matt Verbila, and he uses qPCR for microbial source tracking. So I think you're absolutely right that that's like the next step. For getting not what's the percentage of untreated wastewater, but what percentage is human. I think during
projects that's tractable in that.
Yeah. During dry weather flows, there's no flow ups coming in from anywhere but the sewage system. But during storm flow, you could get a whole mix of stuff. Yeah, that's right.
I want to thank all of our excellent presenters for this session and session 1, and thank you for participating. We had so many people that were able to join us this morning and in the previous presentation.